Hello guys, this video is going to be about the third pillar of object-oriented programming, that is polymorphism. But before we start talking about that, let me just mention one thing that we forgot to point out in our last video about abstract classes. And that is, if we have an abstract method like this, public, abstract, let's say string, prepare statement, and you know that for an abstract method we just put a semicolon at the end and we don't have the body of the method, then what happens is that every class that extends the account class must give an implementation to this prepare statement abstract method. In fact, if we go now to the class Italian account, we see that the compiler is not happy about it. The compiler tells us that there's an error, and the error is that we need to implement the abstract method that was declared in the superclass. We can implement it just as we want, but we have to have an implementation. And the same thing is going to be true for a Chimer account, which is the second class that now extends our account abstract class. So let's go ahead and implement the method even here, even with just a fake implementation. So remember this rule: whenever an abstract class has abstract methods, then the classes that extend the abstract class must give an implementation of those methods. Or even those derived classes could be abstract classes, because in a very complicated design we could actually have an abstract class which defines, let's say, 3 abstract methods, and then a subclass of that class which defines only 2 of them and leaves one still as an abstract method. Then this derived class must also be an abstract class, and finally we'll probably have another class that extends this intermediate abstract class, and if this third class wants to actually be able to be instantiated, then it must give an implementation to the last abstract method that's left inside the intermediate abstract class. Okay, now that this is out of the way, let's talk about polymorphism. In the last video we said that polymorphism was all inside this kind of innocent looking statement in which a reference to a base class points to an object of a derived class. So a reference to the account class points to an object of Italian account class. Why is that so important? Well, the thing is that now that this rule is in place, we could, for example, build an array of accounts, let's say account and ACCS equal new account of 5, let's say. And now the interesting thing is that inside this array I can put both Chimer account and Italian account. So let's say that, for example, in the first slot we'll put an Italian account of, say, 90. And in the second slot we're free to put another kind of class, another kind of derived class like new Chimer account of, let's say, 75. So you see, now it's possible to have a series of accounts in an array and then process them all in one iteration, for example, all in one for statement. Let's say you want to say for, let's say that we have just 2 of these accounts just to avoid null pointer exceptions, and they say for account AA in ACCS, and we can, let's say we want to deposit some money on all of these accounts. We could say AA.deposit, and let's say just then. This for iteration is quite interesting. Why? Because actually this for statement doesn't really know what kind of object is going to operate on. It just knows that they are account classes or derived from account classes, and an interesting thing is that this deposit method will do the right thing, as we have discussed when we talked about method overriding, because it has been overridden in both the Kaiman account class and the Italian account class. So even if the reference here is of the general account class, which method will be executed will be decided at runtime, and it will depend on which object is actually being pointed from the reference AA, and this will be, of course, for the first iteration it will be an Italian account, and for the second iteration it will be our Kaiman account. But I'm sure you're still not very impressed from this possibility, so let's talk about another one. Well, for example, we could go and create a class called account manager, and let's say that this account manager needs to check accounts periodically, so we want to give it a method public void check. So let's uncomment this, and now we have a skeleton of our method, but we have to ask ourselves what kind of type will this account parameter have, because of course we want to check both Italian accounts and we also want to check Kaiman accounts. But if I say, for example, Kaiman account here, what happens is that I cannot, and let me also import the class. There we go. Import 3 pillars of short Kaiman account. If I say Kaiman account here, this method will work fine for objects of type Kaiman account, but certainly not for objects of type Italian account. And this means that I would be forced to create another method that works with the Italian account. There we go. Another method that works with Italian account, even if these two methods do exactly the same thing. So let's say, for example, that they give you 10 euros more if your balance is above a certain limit. So we say, for example, if account dot get balance is greater than 100, then we want to do account dot deposit 10. Deposit 10, there we go. And let's say we want to do exactly the same thing for every kind of account that we have right now. We still have to make two methods, because Java is a statically typed language, and that means that the compiler is very picky about wanting to know exactly what type of parameter a method receives, and it will let you invoke that method only with the right type of parameters. So now we have this problem of duplication inside the two methods, and we could not be able to solve it unless we had polymorphism and class extension from Kaiman and Italian account to the class account. Why is that? Well, because since both Italian account and Kaiman account extend the account class, they are considered as account class. When a class inherits from another class, like for example Italian account inherits from account, we can say that Italian account is an account. For all intent and purposes, the compiler thinks that Italian account can be considered as an account. If you want to be more precise, the compiler is okay with considering that an Italian account is an account, because whatever is in the class account is guaranteed to be also an Italian account, because it gets inherited. So that means that we could create a method check that takes in input a general account class, and through this method we can actually pass every kind of class that will extend the account class. So to this method here, we could pass both a Kaiman account and an Italian account. And what's most important, we will be able to pass to this method every account class that we create in the future, as long as it still inherits from the general account class. So let me change the name of these two methods instead of having a method overloading like I do now, just to make just to be specific about which one we are working with. So it will be more clear which one we are working with. So we call this check C, and this call this check E, check I, and this will be just check. Let us go, if we go back to the main method and we create an instance of this account manager, account manager am equal new account manager, and let's see in practice what I was discussing before. That is, if I try to call the checkC method will take a Cayman account, but I pass it an Italian account, that's not going to work. The compiler is not going to be happy about it, because it will see that this check method is with checkC method is not applicable for the Italian account argument that I'm trying to pass to this method. And the same thing will apply if I try to invoke the check I method, which wants an Italian account. If I try to call it giving it a Cayman account, the compiler is not going to be happy, because let's say 105, because this method is going only because the compiler is only allowing me to pass to this method objects of kind Italian account. It doesn't matter right now that the Italian account and Cayman account are both child of the same class. Why? Because the checkC and checkI method are actually are very specific about the type that are taking in input. This is an Italian account for checkI, and this is a Cayman account for checkC. So these two methods are only and always going to work with object of this precise type. But now the trick is, since Italian account and Cayman account extend the account class, let's make a more general method, check, that takes in input an account class. Of course, we know that the argument that will be passed to this method will never really be of account type, because account is an abstract class, and so we cannot create object of kind account. But just as I was able to assign an Italian account object to an account reference, I will be able to pass an Italian account object to the account parameter of my method. So if I call am.check, you will see that I can pass it both an Italian account and a Cayman account. There we go. Am.check, and let's copy our little object here. There we go. Sorry. There we go. And you see the compiler is very unhappy with these two calls, so let's comment them out. But it's very happy with me passing an Italian account object to a method that takes an account parameter, or to pass a Cayman account object to the same method that takes an account parameter. And that's very interesting, because now I can because now this method is very extensible, in the sense that it's going to work with all the child classes of account, even with the one that I will build in the future. Let's say next year we need another kind of account, no problem. We'll create this, I don't know, South American account. As long as it extends the account class, this check method will be able to handle it with no problem at all. And thanks to method overriding, when an object of a specific kind of account gets used inside this method, and the method get balance and get and deposit are called, the right method will be called. When with right method I intend the method that are defined precisely in that object. So the override of the deposit method in the Cayman account will be called if I pass the Cayman account to this method, and instead the override in the South American account will be called if I pass to this method a South American account. So you see Polymorphism allows us to be extensible, and we know that object-oriented programming is all about extensibility, is all about the open-close principle, is all about being able to have our software open for extension but closed for modification. And here I can certainly extend the capabilities of my application, creating new account classes, and I don't have to modify any of the code that handles accounts, because my code will reason in general terms of an account class. So I hope now that you understand why polymorphism is so useful and so important. And now that we are talking about it, we should remember that for polymorphism to work, we have to be careful to program as much as we can using abstract and general types like our account class. So we want as much as possible to avoid to be explicit about one of the child classes of a general class if a general class exists. So we don't want to create methods that are so specific that, for example, they have to say exactly what kind of child class they are working on. So these methods are a bad idea. So what we want to do is what is called programming by interfaces. Actually, we still don't know what an interface is. We'll explain it in our next video. But an interface, for now, let's just say that it's a kind of abstraction like an abstract class is.